Hi, today I'm here to teach you about direct variation. So a direct variation is a relationship between two variables that is expressed by an equation where one variable is equal to a constant times the other. So one, the y, would be a multiple of the x. K is called the constant of variation, or the constant of proportionality. We say if y varies directly as x, then y over x, or the proportion y over x, equals k, which is the constant of variation. Another way to write that is y equals k times x. So basically, k is a constant rate of change. Sound familiar? It should, because a constant rate of change would make a direct variation linear. A direct variation is linear and k is the slope. So basically you have a line, a linear relationship, and the line has a slope, which is called the constant of variation or the constant of proportionality, and the line will always go through the origin. Now, there's three ways to have a problem that deals with this. One, a word problem. A word problem basically would take you to write a proportion, because if two things vary directly, then you would basically write the proportion y over x and equate it to y over x and solve for the missing piece. Sometimes you'll solve for the constant of proportionality, which is k, but sometimes you'll actually solve for a missing y or an x value. The second way to represent it is through a graph. If two things are varying directly, then the slope will be determined by the rate of change y over x, which is basically like saying the change in y over the change in x, which is the same as the slope. The third way that they can ask a problem like this is using a table of values. If a table of values is given and you're asked to determine whether or not it is a direct variation, what you do is you take every coordinate and you take the y, divide by the x, and come up with k. If the k is the same for every coordinate pair, then you automatically have a direct variation. So let's go to some problems. The first word problem, it'll sound like this. A cake recipe calls for 1.5 cups of milk and 3 cups of sugar. 3 cups of flour, not sugar. Sorry, that would be a lot of sugar. So we don't want to put that much sugar in our cake, and so it's 1.5 cups of milk and 3 cups of flour. If you make a mistake and use 5 cups of flour, we want to know how many cups of milk should I use to keep the proportions correct. Okay, so this is a direct variation. So we're going to write a proportion that represents this. So we can say that the flour is varying directly with the milk. Now, 3 cups of flour is what the recipe calls for, and 1.5 cups of milk and we accidentally used 5 cups of flour. So we don't know what the x is, which represents how much milk should I put in the recipe in order to make up for that. Now the proportion has to remain the same, because when you're making a recipe, your proportions of milk to flour and everything have to remain the same all the time, which is why you have to figure out exactly, you can't just ballpark it, can't guess, you have to figure out exactly how much milk I need. So to solve for this, I want to get x alone. So I can take the x, multiply on two sides by x to get 3x over here, and take the 1.5 milk in the denominator, multiply both sides by 1.5, and I would have 5 times 1.5. And then basically I'm going to take that and solve. So 1.5 times 5 is 7.5. I'm going to take that and divide by 3. I ran out of room. And so x equals, goes in twice, 2. 3 goes into 7 twice, 1 left over. 3 goes into 15 5 times. So basically 2.5 cups of milk. Okay, so this word problem you can use for not only a recipe like this, but you could also use it in terms of like distance and how long will a trip take me if I'm going at a constant speed and I've already driven this many miles for this many hours. So anytime the rate remains the same, you can set up this proportion. And you could solve for the missing pieces according to writing the proportions, as long as you keep the units. If the unit of flour is in the numerator, then you have to put flour in the numerator of the other fraction. If milk is in the denominator, you have to put milk in the denominator of the other fraction. Okay, so how does this appear on a graph? Say you have a graph, and the graph gives you a point and tells you that there's a direct relationship, a direct variation between the point, direct variation for the point 5, 4. So here's the point 5, 4. And I want to find an additional point on the graph, say when x equals, let's see, when x equals, say, -1. Okay, so when x equals -1, I want to know what the y value is going to be of this. It's probably going to be a fraction. So if I know that this is a direct variation, I take the point 4, the y value, divide by the x value 5, and that's my constant of proportionality. So with that rate of change, I want to know what does y equal when x equals 1. So if I'm solving for y, and I know my x value I said I want x equal -1. I place the x value in the denominator. Y is the variable I'm trying to solve for, and you basically can take a cross product from there. So -4 would equal 5y. If I divide both sides by 5, then my coordinate, y, is -4/5. So the coordinate, the point, is -1 and -4/5, which is not quite to the other side, and I'd be able to draw a line through the origin through that point. Okay? Again, if we know that a relationship is a direct variation, then it's definitely going to go through the origin. Okay, there's no doubt about it. It will be going through the origin. It does not have a y-intercept other than 0. That's what it means to be a direct variation. Okay, tables. Say you have to determine whether or not a table of values represents a direct variation. Okay, so I have some x values. I'm going to start 0, 1, 2, 3, and 4. And my y values, let's do -6, -4, -2, 0, and +2. And I want to know if these represent a direct variation. Well, first of all, what do I notice? What do I see here? I have a value for a y-intercept of -6. So right from the start, I can say that no, this is not a direct variation. That even though there is a constant rate of change, as the x's are increasing by 1, my y's are increasing by 2, and so the slope would be a constant rate of change, but this does not go through the origin and therefore fails the direct variation test. Okay, so let's try to think of what would pass. Well, I'd have to go through the origin, but maybe my next point would go up by 5. If that were the case, another 5 would make that 10, 15, and 20. And then when I looked at the change in the y's, 0 divided by 0, first of all, I'm not even going to talk about that because that's undefined. 5 divided by 1 would be the first point, 5, 1, nope, reverse that, 1, 5, and write the proportion 5/1 as the constant of variation. Then the point is 210. So 10/2 reduces also to 5, which is the same. Then I take the point 3/15, 15 divided by 3, that's also 5, which is the same constant. And the last point, 420, if I take the y and divide by the x, it's also 5, which is the same constant. So since they all have the same constant of proportionality, we say that this is direct variation. And that's pretty much direct variation. Okay, take out the worksheet. Anything that I did not explain, you have an additional video by you-know-who to watch, and I need you to fill out your worksheet and do your best and come with questions to class. Bye, have a great weekend.